Hello class, this is Dr. Valenzuela, and welcome to Module 6. I wanted to develop this video for you for the Module 6 discussion, 6-1 confidence intervals discussion. And specifically I wanted to talk about the technical aspects of it to help you reflect on how best to approach it and to respond in this assignment. So when you think about this particular discussion, we have that B&K Real Estate Company sells homes and is currently serving the Southeast region. It has recently expanded to cover the Northeast states. The B&K Realtors are excited to now cover the entire East Coast and are working to prepare their Southern agents to expand their reach to the Northeast. B&K has hired your company to analyze the Northeast home listing prices in order to give information to their agents about the mean list price at 95% confidence. Your company offers two analysis packages, one based on a sample size of 100 listings and another based on sample size of 1,000 listings. Because there's an additional cost for data collection, your company charges more for the package with 1,000 listings than the package for 100 listings. Now, the 95% confidence for the mean of the Northeast listing price has a margin of error of $25,000 for the 100 listings, and the cost of the service is $2,000. And then we have the sample size of 1,000 listings, 95% confidence interval with the mean of the Northeast house listing price has a margin of error of $5,000. Cost of the service to B&K is $10,000. The B&K management team does not understand the trade-off between the confidence level, sample size, and margin of error. B&K would like to come back with our recommendation of the sample size that would provide the sales agent with the best understanding of Northeast home prices at the lowest price for service to B&K. In other words, which option is preferable? Spending more on data collection and having a smaller margin of error? Okay, so that would be this sample here where you're sampling 1,000 listings. It's $5,000 margin of error, but the cost of service is $10,000. Or spending less on data collection and having a larger margin of error. Okay, that's this option here. And then choosing an option somewhere in the middle. For your initial post, you're going to formulate a recommendation, write a confidence statement in the context of the scenario. For the purposes of writing your confidence statement, assume the sample mean housing list price is $310,000 for both packages. Explain the factors that went into your recommendation, including a discussion of the margin of error. For your response post to your peers, you have to choose two different confidence intervals for your responses from your classmates. And then, do you think agents would prefer a different confidence interval than their management? What advantages and disadvantages would there be in a different confidence interval for the agent? Explain your thought process and reasoning in your response. So you want to do that for two of your classmates during the discussion week. Okay, so let's first talk about the definition of what a confidence interval is. When they talk about a 95% confidence interval, it is a range of values that you can be 95% confident contains the true mean of the population. Due to the natural sampling variability, the sampling mean center of the confidence interval will vary from sample to sample. The confidence is in the method, not in the particular confidence interval. If we repeated the sampling method many times, approximately 95% of the intervals constructed would capture the true population mean. Therefore, as the sample sizes increases, the true range of the interval values will narrow, meaning that you know that the mean with which more actually compared with a smaller sample. Okay, So that as the sample sizes increases, the range of interval values will narrow, meaning that you know that the mean with which more accuracy compared with the smaller sample. Okay, that answers part of that question that was in the discussion. So what is a margin of error? A margin of errors in statistics is the degree of error in the results received from random sampling surveys. A higher margin of error in statistics indicates less likelihood of relying on the results of a survey or poll, i.e. the confidence of the results will be lower to represent a population. It is a very vital tool in market research as it depicts confidence level the researchers should have in the data obtained from surveys. A confidence interval is the level of unpredictability with a specific statistic. Usually it is used and associated with the margin of errors to reveal the confidence of a statistician has on judging the results of an online survey or poll and whether they're worthy to represent the entire population or not. So this question now is, how do you calculate the confidence interval with the margin of error? So what you would do typically, let's say you have a range of data values, and what you're going to do is you're going to find the true mean value of the range of data values. And then your confidence interval will be the generic mean is going to be greater than the calculated mean minus the margin of error, okay, less than the mean plus the margin of error, where the mean, this is the generic mean, is not a specific value, but it's just the way that we calculate it. And so when you write the confidence interval and you do this calculation here, you really are going to have a lower bound, and it's going to look like you'll have a lower bound in the confidence interval. Okay, and this symbol here is mu, and it's going to be less than this upper bound that you calculate. Now, let's go to the two different options that they talked about, okay, here. So I'm just going to copy these so that I can work with them. So these are from the discussion. I'm going to put them in my Word document. And so we talked about how to calculate the confidence interval. So here's the two different options. The one with the sample size of 100 listings. Okay, and then another one with the sample size of 1,000 listings. There. And so, and then remember that in the problem it said the sample mean is 310,000 for both packages. Okay, so we're going to assume that the sample mean is 310,000 for both. Okay, so I'm going to put that in my document here for the discussion. The sample mean, oops, there we go, the sample mean is 310,000. Okay, so what we have here is when we want to calculate the confidence interval in both of these cases. Okay, so let's do it for, get rid of this here. Okay, so we want the confidence interval for 100 listings. What I'm going to do is I'm going to take the mean, which is the 310,000, minus the margin of error, which is 25,000. Okay, less than, is going to be less than, this is the generic mean value. Okay, and that's going to be less than the mean, which is 310,000, plus the margin of error, which is 25,000. Okay, when we do the calculation on both sides of this interval, we get 25,000 minus 300 from 310,000, you get 285,000 on the left. I'm going to copy this here, down here. And then we have that, 310,000 plus 25,000 is 335,000. Sorry, I forgot to put this in thousands here. There we go, 335,000, 1, 2, 3. Okay, so this here is the confidence interval, or the 95% confidence interval. Okay, so that means that, think of it this way. If we did 100 different samplings of this particular analysis, 95 times out of 100, we would expect the average list price to be 285,000. The average or the mean list price be between 285,000 and, okay, so we have that, you have a 95% confidence interval. And as I mentioned, if we did this sampling at 100 different sites, the same kind of sampling, same kind of data, 95 times out of 100, we would expect the average list price, the mean list price, to be between 285,000 and 335,000. Okay, so now let's do the calculation for the 95% confidence interval in this 1,000 listings. So we have here, so we're going to copy the formula here, and I'm going to copy it down here. And so we're going to have the mean. Remember, the mean for both is going to be 310,000 listing price. So 310,000 minus the margin of error. The margin of error in this case is 5,000. Okay. There. And then I have 310,000 on the right, plus the margin of error, which is 5,000 in this case. Okay, so if we did the calculation on the left, we have 305,000 is less than the generic mean value. And if we did the calculation on the right, it's 315,000. Okay, so this is the 95% confidence interval. So what we can say about this is that in this case, if we did this sampling, this analysis in 100 different sites, 95 times out of 100, you would expect the average list price to be between 305,000 and 315,000. So when you compare both of these, what you see is that the range with the confidence interval here, with the 100 listings, you can see how big the range is, that the average listing price is between 285,000 and 335,000. Down here, we see that the confidence interval, the range is much smaller, 305,000 to 315,000. that we would expect the mean to be between these two. What this tells us is that as the sampling got bigger, we became more accurate in predicting where those mean listing prices would be. So to answer part of this question, it would cost more to do this analysis for 1,000 listings. It's $10,000 versus 2,000. However, if an industry or a company values accuracy more than it does, maybe it values. So the question is, does the company value accuracy versus being close to the average list prices, right? If they put a premium on having accurate analysis and data and ensuring that the average list prices are going to be between these values, then it is worth paying the $10,000. And so this is really the question that you have to answer in your discussion, right? Is it worth paying more money for that, for a more accurate analysis of the mean average list prices in the 95% confidence interval versus paying the 2,000? And so I wanted to give you this background so that you had a better understanding of how this confidence interval was going to be connected to the discussion. Okay, so have a great week, and I look forward to working with you online this week. Thank you. This is Dr. Valenzuela.